So today I'm going to try to explain to you how to interpret arterial blood gas test results using the Tic Tac Toe method. But before that, I'm going to explain to you why is my Tic Tac Toe in this order. So as you can see, the blood pH is 7.35 to 7.45, so as acidosis to alkalosis. So in this range, it is the normal range. So as you can observe, the partial pressure of carbon dioxide is starting from 45 to 35, because basically if the partial pressure of carbon dioxide is high, it is more acidic. That's why we have to put it here. And for the bicarbonate, we have 22 to 26. So let us work with our number one example. We have, for example, a 7.79 pH with 24 partial pressure of carbon dioxide and 21 bicarbonate. So using the tic-tac-toe method, we have to tic-tac-toe the components. So here we have the pH under alkalosis. And then for the carbon dioxide, we have 24, so it falls under here. And for the HCO3, it is 21. So we have a tic-tac-toe in the side. So we can say that it is a respiratory alkalosis. Now to check whether it is a partial compensation or full compensation, we have to look at the opposite parameter, which is the bicarbonate. And as you can see, it is partially compensating to bring the pH close to normal. It is partially compensating. So you have to write partial compensation respiratory alkalosis. Another example here. Another example is we have a pH of 7.17, carbon dioxide 38, and 12. So the pH is acidic, acidosis, and the carbon dioxide, as you can see, it is normal. Normal. And for the bicarbonate, it is acidic. So we have a tic-tac-toe here. We have metabolic acidosis. And the CO2 is normal, so the CO2 is not really compensating or not doing anything to compensate with the pH of the blood. So we have uncompensated metabolic acidosis. So the last example, we have a pH of 7.45. This one's 48 and 28. So the pH is normal. The carbon dioxide is 48, so it is an acid. This one is 28, so it is basic. So as you can see, we haven't had tic-tac-toe in here, but we can identify or we can interpret this result. So here the pH is pretty normal. It's under 7.45, but the two other parameters are abnormal. So in this example, we know that we have a full compensation because our pH is normal. So we have a full compensation with regards to whether it is metabolic or respiratory. So we have to see which one is closer to, which one of these parameters is closer to the blood pH. So here we have 28 and we have 48. So we have to choose the metabolic alkalosis, because the pH, if any deviation would occur, would become alkalotic. So that is fully compensated metabolic alkalosis.